Using properties of determinant in the following, show that the determinant equal to 1 minus x cube whole square. Now before I start taking the given determinant and see what to do, just see on the right hand side you have 1 minus x cube whole square. Now what are which pattern is this 1 minus x cube? It is of the type a cube minus b cube. Can you tell me what are the factors of a cube minus b cube? The factors are a minus b, the other is a square plus b square plus ab. So here a is 1, b is x. So the factors will be, forget square per minute. So a 1 minus x cube, the two factors will be 1 minus x, and the other will be 1 square, that is 1 plus x square, and plus x into 1, that is x. So our aim is, now if I take square, that means if somehow we could get 1 minus x a factor and again, so 1 minus x whole square, and of course the other factor 1 plus x square or whatever we get first. So here, just see the determinant 1x square, x square 1x, x square 1. So yes, rather if you add say C1 plus C2 plus C3, what do you get? 1 plus x square. We have got the other factor. And we'll get one more later. Right? So we are not directly getting 1 minus x cube, but we'll get a factor 1 plus x square. That's why I discussed that. So now applying C1 to C1 plus C2 plus C3. We get determinant equal to, in column 1, you get 1 plus x square, 1 plus x square, 1 plus x square, keeping the other two columns, that is x1 x square and x square x and 1 s. Obviously, we have to take the factor 1 plus x square common from C1. So you get 1 plus x square common, and you get column 1 as 1, 1, 1, and column 2 and 3 will remain the same as x1 x square and x square x1. And now again, repeatedly you are getting the same situation. You have got 1, 1, 1 in the column 1, what should you do? Apply R2 minus R1, and R3 minus R1 will give you 2 zeros. So replace R2 by R2 minus R1 as well as R3 by R3 minus R1, and what do you get? Already one factor is common as 1 plus x square. So applying R2 minus R1, so at least R1 remains the same, 1 plus 1x square. Applying R2 minus R1, you get 0, 1 minus x, and x minus x square. And similarly, R3 minus R1, you get 0, x square minus x, and 1 minus x square. Now, clearly, this 1 minus x I can take common from row 2, because
I have already discussed with you
steps,
first 4 properties.
This one,
now
this
the properties 5 and 6
minus
which
x
are
square,
very important.
if you take it x common will give you 1 minus x. And similarly, another term here, say this one, when you take x common you get x minus 1, so better take minus x common and get 1 minus x. In this 1 minus x square, I will have two factors, 1 minus x, 1 plus x square. So that means, now as a clear end, take 1 minus x common from R2 as well as from R3. So we'll have rather 1 minus x whole square common. Already this factor 1 plus x square is there, and we are taking 1 minus x common from R2 as well as R3, so 1 minus x whole square. The first row remains the same, 1x square. What do you get in second row? You know it is already in the first column already 2 zeros are there. Now from R2 when you take 1 minus x common you get 1, and already it has been shown here that when you take x common you get 1 minus x. So if you remove 1 minus x you will left with x. And in the third row I have already shown you here that taking minus x common you get 1 minus x. So if 1 minus x you remove, you are left with minus x. And what about 1 minus x square? It has two factors, 1 minus x, 1 plus x. So 1 minus x if you take common, still you left with 1 plus x. And now we have got finally two zeros in simplified form determinant in column 1. So expand along column 1. Expand along column 1. So 1 plus x square into 1 minus x square is already there. Expanding, what do you get? 1 time 1 into 1 plus x, that is 1 plus x, and minus plus x square. And other two terms are already 0. So we have got here from inside the bracket 1 plus x square again. So you get 1 plus x square whole square as well as 1 minus x whole square, which may be rewritten like one factor each, 1 minus x into 1 plus x square whole square. In this I have discussed with you right in the beginning that the product 1 minus x into 1 plus x square is like a minus b into a square plus b square plus ab. So product is a cube, 1 cube is 1, minus b cube, that is x cube whole square. And that is what is your required right hand side.